Alright, today we're going to solve the integral of 1 over x cubed plus 1. As we can see, this is a partial fraction decomposition, so we're going to break down the denominator first. And that can be breaking down into x plus 1 times the x cubed minus x plus 1. This comes from the sum of cubes. Now the denominator is broken down, I'm going to rewrite the integrals as 1 over x plus 1 times x cubed minus x plus 1. Now we're going to use distinct quadratic factors to break it down. So 1 over x plus 1 times x cubed minus x plus 1 equals to a over x plus 1 plus bx plus c over x squared minus x plus 1. Then now we're going to multiply by both sides. So now 1 equals a times x squared minus x plus 1 plus bx plus c times x plus 1. And now I'm going to speed it up a little bit. So what I'm trying to do is setting x equals to 0 and try to solve for a, b, and c. And setting x for 1 to solve for a, b, and c. And setting x as negative 1 to solve for a, b, and c. Letting set for x to 0 and 1 did not give me a value, but when I set x to negative 1, I got a as 1 over 3. Then I plugged it a back to the 1 equals a plus c, and I got c as 2 over 3, and plug the rest back into the 1 equals a plus 2b plus 2c, and I got b as negative 1 over 3. And now I'm going to plug all the values back into the integrals. Okay, now we're going to take out the constants that's inside the integrals. And for the second part, we're going to take out a negative 1 over 3. So now the numerator is going to be x minus 2. We can try to integrate the first portion of the integral, which is 1 over 3 ln absolute value of x plus 1 minus 1 over 3 of the integral of x minus 2 over x squared minus x plus 1 dx. We got the first part, and we'll deal with the second part right now. So we're going to focus on the denominators of the integrand, which is x squared minus x plus 1, and we're going to set that as our u. Thus, our du is going to become 2x minus 1. Alright, so our next of operation is trying to make x minus 2 look like 2x minus 1. So we gotta do some manipulations. So all I'm gonna do is I'm gonna time 2 and divide it by 2. Alright, so now we got 2x minus 4 over 2. And let me just put back the 2 I just erased. And now we're halfway there. The only thing that's kind of in the way is the negative 4 over there. So without changing anything, all we have to do is make it as negative 1 and negative 3. Because in the end, they'll add up to negative 4. Then I separated the numerator, but it's just me. You can do whatever you want. And now just plug everything back into the integral, and now you got this. And now we can rewrite this as negative 1 over 3. In the parenthesis of I took out the 1/2 from the numerator, the integral of 2x minus 1 over x squared minus x plus 1 minus the integral, actually 3 over 2 of the integral of 1 over x squared minus x plus 1 and dx. Okay, now actually we don't have to do any work for the first integral, so negative 1/3 in the parenthesis of natural log, sorry, 1 over 2 of natural log, absolute value of x squared minus x plus 1 minus 3 over 2 of the integral of 1 over x squared minus x plus 1 dx. And that is going to be the last integral we're trying to solve. Okay, now we are going to bring the integral down, negative 3 over 2, in the integral of 1 over x squared minus x plus 1 and dx. So what we're going to do right now is trying to complete the square for the denominators. So x squared minus x plus 1, and that is going to equals to x plus 1/2, sorry, minus 1/2 squared. All right, so if we distribute or multiply out the x minus 1/2, we will get x squared minus x plus 1 over 4. So what do we need to do in order to make that a perfect square? So what do we need to add to 1 over 4 to make into a 1? 1 minus 1 over 4 will give us 3 over 4. So the denominator is going to become x minus 1/2 squared plus 3 over 4. And now let me just spend some time to rewrite the integral. And now we are pretty close to a tangent substitution, which is 1 over u squared plus a squared, which after we take the integral will give us 1 over a arctan of u over a. So in order to make our integral looks similar to that, we have to quote unquote take out a square from 3 over 4, which is going to become a root of 3 over 2 squared. And I forgot my square in my denominator. And so now all we have to do is do a simple u substitution where the u is going to be x minus 1 over 2 while following the template of the formula for the integral of the inverse tans. And the du of x minus 1/2 is just going to be dx. And now we're just going to plug u back into the integral. And then we can integrate the integral. All right, then I'll simplify a little bit. In the end, we'll got 2 over square root of 3 inverse tan or arctan in the parenthesis of x minus 1/2 over square root of 3 over 2. I'm going to simplify what's inside the arctan because it looks pretty messy right now. We know that x minus 1/2 can be rewritten as 2x over 2 minus 1/2. And that will give us 2x minus 1 over 2. Plug it back in, 2x minus 1 over 2 over square root of 3 over 2. Now the 2 cancels out. All we got is 2x minus 1 over square root of 3. And plug that value back in, and we just solved our last integral. All right, our next step is to combine everything and simplify. All right, with all the answer we highlighted, and don't forget the constants, we will have 1 over 3 of natural log of the absolute value of x plus 1 minus 1 over 3 in the parenthesis of 1/2 natural log of x squared minus x plus 1 minus 3 over 2 in the parenthesis of 2 over square root of 3 inverse tan in the parenthesis of 2x minus 1 over square root of 3. And close all the brackets and parentheses, plus c. Alright, and now all we gotta do is to distribute the negative 1 over 3. And lastly, distribute the 1/2 to the 2 over square root of 3 inverse tan in the parenthesis of 2x minus 1 over square root of 3. And now our final answer will be 1 over 3 natural log of absolute value of x plus 1 minus 1 over 6 natural log of absolute value of x squared minus x plus 1 plus square root of 3 over 3 inverse tan in the parenthesis of 2x minus 1 over square root of 3 plus c. And that is our final answer. It'll be a lot easier if I just have a 1 over x squared plus 1. But anyways, thanks for watching.